Hello, and welcome to the first annual physics and baseball game.
This game will be a real tough match with so many different external forces working with and against these players.
Right you are.
Oh, look right there, Ellen. That ball right there is a great example of Newton's first law of motion. See how the ball isn't moving?
Yep, I do.
Well, it won't be moving anytime soon. That's because Newton's law dictates an object at rest will remain at rest.
Unless an external force acts upon it.
Exactly. Do you see any examples of an object in motion for Newton's first law?
Why, yes, I do. See the player over there, sliding into first base?
Yeah.
Well, he would have kept on sliding forever according to Newton's first law of motion if it weren't for the external force of friction.
Oh, and this is the perfect time to introduce Newton's second law. It describes the relationship between an object's mass and the amount of force needed to accelerate it.
A great example of this is right before our eyes. See how the hitter is hitting the ball into the outfield?
For sure, the force of the ball is the mass of the ball multiplied by the acceleration of the ball.
Exactly. And the force of the ball after the pitcher throws it to the batter is 9.5 newtons. So the force of the bat has to be greater than 9.5 newtons in order to hit the ball into the outfield.
Newton's third law tells us the force of the ball after it is hit, because for every action there is an equal and opposite reaction. The action in this case is the bat swinging and hitting the ball. The reaction is the ball getting hit and going 110 miles per hour due to the force of the hit.
After the ball is hit into the outfield, we can see projectile motion taking place as the ball creates an arch shape along the earth. The ball goes upwards when it is first hit, but slowly curves down towards the ground as gravity acts upon the ball.
During the game, we have seen perfect examples of sliding friction, potential energy, kinetic energy, and conservation of energy. When players slide onto a base, sliding friction is shown. When they slide onto the ground, they rub into it, creating this type of friction. Conservation of energy states that energy cannot be created nor destroyed, so the total energy will remain the same. Conservation of energy can be seen when a player hits the baseball with the bat. The force and energy of the bat transfer over to the baseball. Kinetic energy is shown when a player throws or hits the baseball with a bat.
Oh, and look, that's a home run. Well, that wraps up the game today, folks. Thanks for tuning in to learn about how physics plays a role in baseball.
Newton's laws of motion are 3 physical laws. They teach us motion and gravity. Law of inertia is super whack. Let me learn about physics. 'Cause Newton's a really chill guy. 'Cause it's force, work, acceleration that keeps us moving.